Okay, so now the question is, does our set of matrices, these four matrices, span M22? Well, that's going to give us this system, or this matrix equation, okay? Linear combination of these matrices, same thing we saw before, equal to an arbitrary vector in M22. This is just any member of M22. So I've just denoted it by the matrix A11, A12, A21, A22. So if this equation always has a solution, then there's always a C1, C2, C3, C4 that which when multiplied by the four matrices and added and so forth gives us whatever vector we're trying to find in M22. And that would establish that the set is a basis, because we already established that it's linearly independent, and now we establish that it spans the space, because if we can get any vector in the space by a linear combination of the vectors, it's spanning the space. Okay? Well, we could, and we would, again, expand the left-hand side, express the left-hand side as a matrix equation with a matrix times the C1 through C4 vector, and set it equal to this, and ask if there's a solution. The answer is the same as before. Yes, there is, provided the matrix is invertible. And we already saw that it is, so our set is a basis of M22. So what it comes down to is take this linear combination, write it as a set of simultaneous equations, four equations in this case, express that set of simultaneous equations as a matrix equation, multiplying this matrix by your C1 through C4, and set that equal to 0. Solve it to see if the C1 through C4 has to be 0. And then, if that's the case, set it equal to this matrix and see if you get a solution for C1 through C4. In both cases, the answer is going to be yes if this matrix is invertible. Okay, so that shows that our set is a basis of M22, except that I wrote the matrix down wrong previously. I wrote the matrix down correctly here, and you can check if the actual matrix for the four vectors that I listed here really is invertible by checking its determinant. I would expand it either across the bottom row or across the second row, or if you prefer, along the second column or the third column. Each case you have two zeros in the row or column, making it fairly easy to check the matrix out. Okay? Our conclusion is, well, I'm going to summarize the process. Just step back and summarize the process in our next clip.